Friends, welcome to part 3 of our video presentation on chapter 8. In this part, we will talk about several things. First of all, we will talk about the so-called Systems Development Lifecycle or SDLC framework. A lot of people view this framework, this SDLC framework, as a central concept or central framework of the entire field of information systems. After that, we'll make a distinction between procedural-oriented and object-oriented design, system analysis and design methods that are used at various stages of system development lifecycle, but mostly during the definition and construction phase. In fact, I would say that the kind of procedural logical modeling approaches that we will discuss, they provide a link between the definition and construction phase. And then we'll talk about several specific procedural system analysis and design methods that seem to overlap with that overall systems view perspective that we discussed in previous parts. But first, let's talk about the SDLC framework. I told you, I would like to repeat this again, that a lot of people in the field of information systems view this framework as something that is central to the entire field of information systems. In fact, if you think about the main purpose of this framework, that would provide some support for that view. The overall intent of this system development lifecycle framework is to describe, to provide a high-level description of how information systems are conceived, designed, and implemented within organizations. So some people would say that information systems, or computer information systems, or management information systems, as a field, it's largely about creating knowledge in those three areas: system definition, construction, and implementation. By the way, there are many variations of this framework. I've seen many steps being included in those phases. So this is like a high-level summary of different versions of the system development lifecycle model. Once again, basically this model tells you that in order for an organization to develop an information system solution to an organizational problem, or in order to develop an information system within an organization, you need to go through the definition, construction, and implementation phases. And each of those phases may have a number of sub-steps. And the job of an information system professional is to oversee the steps, the deliverables, the processes, and the people that participate in those three phases. So let's talk about each of those three phases in a bit more detail. Now, during the definition phase, that once again may involve a number of steps, end users and system analysts, they conduct a multi-step analysis, or they work together of the current business operations and the information system or systems in the area of concern. So basically, in this step, we're trying to define a problem. We're trying to do a great job in terms of analyzing various aspects of a particular organizational problem. And by the way, this organizational problem can be centered on an outdated, let's say, information system. So that's the definition phase, trying to understand the organizational problem. Now, during the construction phase, you design, build, and test a system that satisfies the requirements developed in the definitions phase. And once you design and build the system, you go ahead and implement it. You install the new system, and that involves a number of things, such as converting old data into new databases, and developing new processes for end users, for people to use the system. So implementation phase is also very important. So this is like a very high-level rough summary of those three phases. Now, as a part of system development lifecycle, or throughout virtually all steps of system development lifecycle, information system specialists or system analysts, they used a number of system analysis and design techniques. And those techniques, they fall into two broad categories: procedural-oriented and object-oriented. Now, the essence of procedural-oriented or process-oriented system analysis and design methodologies is that there is a certain process, and a system analyst needs to go through the steps of those processes to design a model of an information system. Now, object-oriented, it's not like that. It's reliant on a collection of various objects, and the job of a system analyst is to make sure that those objects are put together in a way that satisfies or addresses the organizational problem. I mean, put together in the form of a model. Procedural-oriented methodologies are very common. They're still very common, but object-oriented methodologies, system analysis and design methodologies, are gaining momentum, are gaining popularity. Now first let's talk about the essence of procedural or procedure-oriented system analysis and design methodologies or techniques. So this is the essence of process-oriented techniques. Describe what you have, define what you want, and describe how you will make what you want. In other words, first of all, you need to document as-is situation, the situation that you currently have within your organization. As a second step or second high-level phase, you need to create a logical to-be model. In other words, the state of things is described here, and there's something wrong with the current state of things. So you need to create a model of how things should be like in the future. Okay, and then once you create this future vision in the high-level logical form, you translate it into physical to be, meaning like the physical implementation of that logical idea. Okay. So let's talk about each of those three phases in a bit behind the procedure-oriented techniques in a bit more detail. Well, the first step or phase, as is, documenting as is. Basically, what you need to do, you need to identify existing processes, external and internal participants of those processes, various databases and applications, inputs and outputs. In other words, you need to describe the way an information system currently is using that broad socio-technical perspective. In other words, you need to describe processes, you need to describe applications, data, and so forth. Okay. Now, once you understand how things are, you may narrow your analysis to one specific problem, and then you need to develop a logical solution to this problem. Now, what's the essence of a logical solution? Now, a logical model describes what rather than how, meaning the focus is on principles rather than technical implementations. Now, this is something that is, that helps to avoid the so-called technology bias. There's a saying that goes something like this: to a person with a hammer, everything looks like a nail. Now, the essence of information system as a field and the essence of the systems view is that, business comes first, and it's not some kind of, it's not a matter of belief. I mean, organizations are largely about accomplishing business goals. I mean, if business goals are not accomplished, if profits are not generated, then there's no money for technology or for anything else. So business always comes first. So logical models, they concentrate on logical, understanding, business understanding of the problem, rather than technological understanding of the problem. Logical models, they're also high-level models of non-existing new systems. In other words, they basically describe how a new system should be like. They do identify processes and data, but again, they stay away from technology. They focus on organizational data and organizational processes. They may not identify who does the activity, where it's accomplished, or the type of hardware and software that is used. Again, to avoid like this technology or people biased. And then once you create those logical models, logical to-be descriptions, you translate them into physical to-be. You map the logical requirements to available technology, meaning specific hardware and software technologies, as well as database technologies supporting your data or process requirements. So this is the essence of procedure-oriented techniques. Now, one simple example of a procedure-oriented technique for creating logical models is the so-called context diagram. Context diagram means like the essence of the new system. So here we have the following description. We have several participants in the system. We have a vendor. We have accounting department, we have purchasing department, and then there is a process, in relation to processing accounts payable. So vendors are sending vendor invoices to this process, and then as a result of this process, vendors receive checks or rejected invoices, and then the process also generates summaries of accounts payable for the accounting function, and then purchasing, probably the main participant in this process, creates purchase orders using this process. Now, eventually, this process will be implemented as a software, as an information system that will be supported by a number of interfaces for those participants, and also by a data structure, by a database that would support all those information exchanges and will store all those messages and outputs. Okay, but as you can see, this is like a very simple logical model that says, well, in essence, if you want to build an information system solution for streamlining accounts payable, something that may be a big issue for a big manufacturing organization such as Ford, that has a lot of vendors, then the essence, the logical essence of that model would look something like this. Now, there is another popular procedure-oriented technique called data flow diagram, or DFD. I mean, I would say it goes one step beyond the context diagram. It goes into details in relation to external agents or external entities, the kind of data being sent, in and out of various processes. Provides a greater description of the processes involved in information systems, and also outlines data stores. You can think of those as like databases or parts of databases that support an information system. So data flow diagrams are extensively used in logical modeling. They are used also outside of the information systems field. For example, they're used in accounting to describe an information flow or processing flow of an accounting information system, even if it's manual, even if it's not implemented using technology. So here we have basically a DFD model based on the context diagram that we discussed previously. So we have several participants. Again, we have a vendor, we have accounting department, and I don't see purchasing department, just like for illustration purposes. But in the previous diagram, we also had purchasing department. Those are the kind of processes that will be implemented with the system. Let's say summarizing accounts payable, and this information will be sent to the accounting. And this is a data flow, by the way. Those arrows represent data flows or exchanges of information or messages. So we have all those processes. Then we have a number of databases or data stores, as they call them in DFD modeling. We have a database storing information about purchase orders. We have a database storing information about receipts and so forth. So you see, like in a way, we're staying away from technology. We're saying there are certain processes, there are certain participants interacting with those processes, and there are certain databases supporting those processes and data flows. But we're not getting into actual details about the database technology, about the software or the programming language that will be used to implement those processes. We're not, or the types of interfaces, let's say web interfaces, that will be used for sending those messages. Here we are dealing with the things in principle, how things will be, how things will work in principle, right? So we are focusing on business rules. As a part of any kind of procedure-oriented system analysis and design methodology, you may use data dictionary or data directory, where you will basically keep track of your entities or variables, the things about which you need to store data. Another famous procedure-oriented system analysis and design method that is focused explicitly on modeling data requirements, meaning those data stores that you just saw in the DFD model. It's called Entity Relationship Diagram Model, ERD. If you took a course on a database modeling or design, you probably know that ERD modeling is a vast topic. There are so many things to cover. There's entity discovery, there is normalization, various normal forms that you use to simplify and improve, robustness of your model. There's cardinality, all kinds of, and then you have all kinds of complicated relationships among those entities. So it's a big topic. So this is just like an illustration. So in this ERD model, we're basically saying that this information system will need to store data about checks, about vendors, about receipts, about purchase orders. Here we have specifics of data stores, the kind of attributes that will be created to store information about purchase orders. And this is how this data will be related, because you need to keep track of those relationships to make sure, for example, that update in one entity is cascaded properly to other entities. For example, if you delete a vendor from your database, you may want to do updates to accounts payable or invoice payable entities, so that if you're no longer doing business with this vendor, so that information about accounts payable is removed from the database to simplify the database and decrease storage requirements. This is an example of a physical to be model. So giving this kind of information system, giving our data requirements, you may end up building an interface like that. So this interface relies on data attributes that are outlined here, and it also supports one of the processes, for example, and one of the external agents. For example, an interface like that can be used by a vendor to send messages to the system to the part of the system responsible for approving invoices. Okay, so this concludes part 3 of our video presentation on Chapter 8. Thank you for listening.